All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are gonna continue learning about polars. Now, I'm not planning on spending the next week of streams doing just polars. This is probably gonna be like one of the few polar streams because I do want to get back to doing Godot stuff and sorry, and I pretty much only do Godot stuff on stream. So I would prefer to, get back to Godot. However, um, I recently got into pandas, and how do I say this? It's just one of the things that's grabbing my attention right now. It's one of the things that I'm really interested in learning, and I'm hoping to also take this knowledge over to the Rust side and then hopefully do data analysis in Rust as well. Because I'm still trying to decide whether I want to do data analysis on the Rust side or on the Python side. Um, I've done data analysis and data handling on the Python side. I know that there's a pretty mature ecosystem of tools and plugins and well tools tools and libraries and stuff um, within within Python. It's a very mature ecosystem when it comes to anything data science related. Python is like the first thing that comes to mind. Well, no, that's not entirely true because R exists as well. So I shouldn't say it's the first thing it's the first thing to come to my mind, and actually a lot of other people as well. However, other languages do exist like R. I think Julia is one of them. I don't remember. I don't remember exactly what Julia gets used for. That sounds that sounds weird. Julia the language. Okay, Julia language. Uh Julia is a dynamic general purpose programming language. As a high level language, distinctive aspects of Julia's design include a type system with parametric polymorphism, the use of multiple dispatch something something. Okay, um, Gemini is giving me a bit of an overview. The Julia programming language is a high level, high performance, and dynamic language, primarily designed for scientific and numerical computing, data analysis, and machine learning. It aims to solve the two language problem by providing the speed of compiled languages like C or Fortran with the ease of use of scripting languages like Python or R. Okay, so R and Julia, these are also two options. So I shouldn't say it's the first one to come. What did I say? That there was a statement that I made previously that I was trying to correct. Something about like Python is the first thing to come to mind when you think about data science. That's not entirely true, though. The Python ecosystem is pretty massive. It is it is massive, like crazy big. There's a lot of different libraries for solving various types of problems. These are very sophisticated libraries. Like if you look at something data science or data analysis related, you have for the analysis part for the data science part, you have actually data analysis would also come under this. But yeah, for the data science part, you have libraries um, like scikit-learn and SciPy, and a couple of others as well. Scikit-learn is very heavily used because there's a lot of data science algorithms that have been implemented in it. And then for data handling, data processing, and stuff, um, you have libraries like Pandas and now Polars as well. Uh, for data visualization, you have some of the top what do you call them? Some of the top libraries are Matplotlib and Seaborn and Plotly. That's another one. And aside from that, there are a couple others as well. So my point is, Python is a very it has a very growing, very thriving ecosystem, very mature as well ecosystem when it comes to data science and data handling, and even going into higher level stuff like machine learning and deep learning and all. Python has a very mature ecosystem. Rust has a growing ecosystem. I don't necessarily know if it's, or I don't know if it is necessarily mature, but it's a growing ecosystem, and it's a lot of people tend to be moving towards the Rust side because, well, specifically they're moving towards the Rust side when it comes to performance related stuff. So like if you want to do things real time, which there are quite a few applications that do require real time use of these various algorithms and real time data handling and stuff like that, you probably want to go with something that's Rust based because there's a lot of optimization that can be done, and just by default, the language is pretty fast. As an added bonus, depending on which library you are using, you might even be able to run your program on embedded devices. And I say depending on which library you are using because the library has to have no STD support because STD, which is a standard library, it's usually only available on like when you have like a full-fledged operating system because there's a bunch of features in there, stuff like I don't know, the heap, the ability to print to a console, um, multi-threading, that's another one, and a couple of other capabilities that are usually provided by the operating system. And so the standard library would be communicating with the operating system in order to provide that functionality. However, if you are running your program on an embedded device, um, a lot of times you don't necessarily have a full-fledged operating system like, you know, something Linux based or Windows or whatever. Like if you're running on an ESP32, quite often, if you're doing bare metal ESP32, then you're running your program directly on the hardware. You're not there. There isn't a kernel. There isn't an operating system. You're just directly running your program there. And if you are using the Espressif IDF, that's their, I forgot what the full form of that was, something development framework, integrated development framework, I think. I don't remember. But yeah, if you're using, so Espressif does provide a thing. It's a, it's a sort of, um, in a way you can consider it kind of an OS because it does give you certain features. It gives you access to certain features. It's not an OS um, in the way that Linux is an OS or Windows is an OS, but like it does provide you with a set of features that would be considered, or that would, well, I don't know if that would be considered OS like. I was about to say that, yeah, that would be considered OS like, but kind of in a way. It provides you with a set of features. That's what I'm trying to say. And I think in that case, you might be able to use STD, at least on the Rust side. So if you're doing ESP32 Rust programming and you want to do STD based programming, it has to be using the Espressif IDF framework. But if you are like me and you want, and actually like a lot of other people, if you want to do bare metal programming, then generally you have to go with the no STD approach. Now, keeping that in mind, just because the STD approach provides you with these features, and no STD doesn't provide it out of the box, doesn't mean that that functionality doesn't exist at all. You do have implementations for various things. Like there was some sort of heap implementation. I don't remember exactly the details surrounding it. I guess I'll get into it once I move forward with the ESP32 development. Um, but yeah, there are libraries that provide you with these features. So you do have, I don't know about multi-threading, but you do have async programming through crates like Embassy, for example, and you have some sort of heap allocation, some sort of heap implementation. Sorry, you have some sort of heap implementation through another library, and in terms of printing to the console, you don't necessarily have a console to print on. However, if your ESP32 is currently connected to a computer and you have like an active session going on, you would be able to send like print messages to print directly to your console. So there are ways around all of that stuff, and the bonus is that you are still running on bare metal and you're able to get a lot more out of the hardware in terms of resources. Okay, all right. So let's get back to polars. By the way, I spent yesterday um, learning about tab U. I don't know if yesterday I was calling this tab view. I think I might have been calling it tab view. And then yesterday when I was trying to install it, I paid attention to the spelling of it. Apparently it's spelled as tab view without the V. So it's tab U, as in a view of a table, I guess. I guess that's what they were going for. And they have a nice wiki set up in which they're teaching you about this program. So something that I loved is that you have a theme selector. You can change the theme of this to whatever you want. And it does have my favorite Rose Pine Moon. However, something that I noticed, one small thing that I need to either request someone else to change or I need to create my own pull request for it. I think I'll create my own pull request. It's a very small change that needs to be done. However, I need to test this out on my system before I suggest the the change. What was I saying? Yeah, one small change that I need to suggest. Actually, I've noticed this in a bunch of other themes that they've provided as well. If you pay attention to the thing that's being highlighted, so right now I'm highlighting Rose Pine Moon, and you can't read Rose Pine Moon because the highlight strip is a very light color. It's not white, but it's very close to white. And Rose Pine Moon, the text is actually white. So this is like a light color on a light color, and so you can barely read it. As a result, this is what happens. If I'm selecting any specific row, if I have a specific row highlighted, I can't see the details in it. And I've noticed this with a couple of other themes that they've provided as well. But I want to use Rose Pine specifically, so I'm going to make the change for Rose Pine and any of the other Rose Pine variants. So they have Rose Pine, they have Rose Pine Dawn, and they have Rose Pine Moon. For the time being, though, I'm using Capuchin, which is this. And even in Capuchin, so I personally like Capuchin Mocha. If I'm ever using Capuchin, I usually go for Rose Pine. But even in Capuchin Mocha, I noticed the same thing. And it seems like, so I looked at the repo, and in the repo they have a themes folder in which they have created Rust files for every single theme. And so you can just open the specific Rust file for, or well, you can open the Rust file for the specific theme. That's what I was going for. You can open the specific words. You can open the Rust file for whatever theme you are looking for, and the colors are mentioned there, and there's a specific like body of I forgot exactly what the format was there, but they have defined it. Do I have the thing open here? Wait. I'm probably not going to open it on my on the laptop that on the laptops that my God, dude. on the laptop that I am currently streaming on. What is going on? I cannot speak. Right, hold on, wait. Um, this was TUI. Under TUI, we have themes, and under themes, oh, you know what I can do? I can copy the entire thing. So Rose Pine Moon. Let's copy the raw file, and I'll just drop it here. Give me a second. I'll need to create a new thing. So let's say scratch. Yeah, there it is. Scratch, I don't know, scratch O1. Okay, paste. This is the entire thing. This is the Rust code. I actually didn't pay attention to this because, well, I didn't pay attention to the entire code structure because my mind immediately went to looking at the colors. So now that I'm paying attention to it, um, it seems like these are, okay, it says public struct. Okay, okay. So we have the struct, this, then if that is the case, um, up top they might have something, right? Or would there be like a mod? Or would there be maybe a theme file? Hold on. Okay, so there's a mod rs here. In mod rs, they've defined, oh, there it is. Okay, here's what they've done. In mod rs, I'm just going to copy the entire thing. This is what they've done. They've done mod rs, and just like this, for every single theme, they've defined a separate module, and that's how they're doing it. This is great for separation because, as you can see, this is a very small module, right? But to be able to edit the theme, this is great. So for the sake of organization, this is actually pretty great. Yeah. So I need to go in and experiment with the colors. My this caught my attention. Highlight, foreground. So my assumption is highlight is basically, you know, whatever is currently being highlighted, and there are specific situations where you would have a highlight. So when you're looking at the tab view, which by the way, this is great. This is amazing. I also found out how you can have multiple tables open, how you can, like, let's say you open up multiple CSV files, you can do shift and left or right to switch the table. This is such a useful application. I'm also noticing right now that you guys cannot see the entire UI, the entire TUI of this program, which is unfortunate. But there's not much I can do about that. Is there something I can do about that? Well, okay. At the bottom, there, at the bottom of the UI, what you guys are not able to see, which is actually the last 2 or 3 rows. So below this, you have below what you guys are currently seeing, which is T017 or row 17. There's row 18, 19, and 20. So those are 3 separate rows. And then there's one more row below that, which is sort of the end of the border. So the bottom part of the border, there's a border kind of thing set up here, which you can disable, by the way, and that gives you one extra line in case if you want that. This is, dude, this is great. This is a very customizable application, and this is a very, like, this is an application with a bunch of different very useful features. Like, check this out. Hold on, let me enable border. Oh yeah, I was talking about like what's beneath. So okay, we have the, like, you can see now there's no selection being shown, and that's because that's disappearing in the view that you guys are able to see. But like, I'm looking at this on a bigger screen, on actually another screen, so I'm able to see it. So I'm just going to describe it. At the very bottom, the very last row, it's sort of a status bar that mentions the name of the table that you're currently on, and the tab that's currently on. So it's like if you have three tabs open, then which tab are you currently viewing? Tab 1, 2, or 3? I'm currently in tab 1. This is tab 2. This is tab 3. So yeah, there's that. And then there's the row number, so which row you're currently on, and also the shape of this table. The shape is basically, because this is a two-dimensional table, so it's giving you the row by column count. So how many rows by how many columns. And yeah, so that's the bottom part. Additionally, you can have information about the entire table. You can also have, well, you have this tab thing to select between, like it gives you a list uh, to select from. Additionally, you can just do, shift left and right. Oh, you can also look at the information of each row in a more like magnified way using this. So that's pretty useful. There's also you can also use SQL queries to like select specific data. Like so the SQL query thing, I feel like it's a little on the tedious side, because like it's error prone, and when you make an error, you kind of have to type the entire thing again. So the error prone part is like you can make an error, not the application. Okay, select star from logistics underscore data, where actually where price is less than 100. So now it shows you this. And additionally, what this has done is this has opened up a new tab in which these filtered results are being shown. So you will notice price. The price for every single row here is below 100. So it has filtered out the results and put them in a separate tab. And you can just hit Q to close that tab. This is so useful. This is incredibly useful. There's so many things that you can do with this. Additionally, if you ever open up a file in a specific format, you can then also export it in a different format. Look at that. That's crazy. I actually tried exporting it. I don't remember if I did that on this system or another system, but I can export. Where's export? Up here. I can export. I currently have a CSV file open. I can export this to JSON. What is the time? I only have an hour and a half to stream today because I have to do some cooking. Yeah, okay, I have like an hour more. Yeah, yeah. Okay. So, I can export this to JSON. I could try Parquet as well, but then we won't be able to read the thing because it's going to be in binary format. So, I'll export this polars datasets. Yeah, let's say logistic. I don't want to have the same thing. So let's say some JSON.json, some JSON o1.json. Okay, data frame exported. If I should I go to the next tab here? Yeah, yeah. Okay. Let's go back, go into polars. Then datasets. Do we have it here? Yeah, some JSON o1. So if I read out or if I use bat to list out or print out whatever the data, this is our JSON data. Bat by itself, by default, doesn't, at least from what I've seen, it doesn't process the JSON. So you can't do like pretty print. However, what you can do is, list this out and then use JQ, which is a JSON processor on Linux. You can pass that entire blob of text. Generally, JSON is going to be as like a blob of text because they strip away all the all of the unnecessary stuff, like tabs and spaces and new lines and all of that stuff. So it helps shorten the size of the image. And in the end, if it's if the JSON is not meant to be human readable, or if it's not meant to be read by a human being, if it's just meant to be processed by a computer, then you have no reason to uh, have all of the extra tabs and spaces and stuff. It's just a waste of bandwidth at that point. Okay, so we can do bat and then pass that JSON blob into JQ. Something that I love about bat is that, okay, check this out, right? When I do this, you'll notice the text is there, definitely. The text is there. However, there's also these extra like lines and stuff that they've done for the sake of organization aesthetically. Wait, you guys can't see that. Is there a way that I can? Oh, I could, let's say, echo ABC bat. So this is what I'm talking about. These like table lines that you see. This is what bat does. Yeah, you can see the bottom line, and you can see the border on the side. So all of these extra characters are there, right? You might be concerned that this information is gonna show up if I try to pipe this into something else. However, what was the way to get Echo to do it? Okay, my point is, that's not what happens. It doesn't pipe all of these extra, the borders and stuff in. So for example, if I do this, all it's going to do is, so JQ dot means it's taking input from standard input, meaning you can pipe the output of another program into it, and then it's gonna do its processing, and what you end up with is this completely, you know, um, a processed, pretty printed JSON block, and then you can again pass it into BAT, and this time use the language flag, mention JSON, so it does its whole, like coloring stuff. So this is, yeah. Give me a second. Okay, all right. I forgot why I was doing this. I forgot why I was. Oh yeah, it was to show you that the JSON data can be exported. So yeah, this is if you look at this last thing here, it says T1 100, and then if we go back to this, the very last row is T1 1. Actually, you can't see the very last row. You can't see it. I can see it, but let me go up to something that you would be able to see. Let's say T 1095. That is this. T 1095 is here. This is all the data for T 195, and you can see T, not 195, 1095, and this is T 1095. Okay, so enough with, what do you call it? I forgot I was having this conversation with Gemini. What was this about? I just bought a couple of, oh, okay, yeah, that's fine. So we are gonna, let me just delete this entire thing. Okay, save, go back here. Okay, we're gonna get back into polars, and we're gonna try and make some more progress today. We are not looking at the Rust side right now, though eventually I do want to get into the Rust side of things as well. But yeah, I would definitely like it if like in the future, if I'm working on any data science related thing, um, then if I'm able to use polars instead of pandas, I would like that. I would definitely prefer that because having looked at the API of polars versus pandas, and I mean I have no experience in polars. We are currently learning polars. I do have experience in pandas, and based on that experience, and after then looking at a couple of just having a glance at the API of polars, I kind of like what I'm seeing in polars. That being said, I haven't tried any of it yet, so I guess we'll find out what the like. I guess what's the right term to use there? I guess we'll find out ergonomically how good the API is, and if the API is ergonomically good at all. Okay, all right. So we were. Oh, what is going on here? Oh, wait. Now we can scroll down. Yeah, dude, this was something that I really liked about. Oh, you know what I'm wondering? I'm wondering. I need to ask Gemini this question. Hey, so I recently started using the BAT bracket Rust program. I like it, pretty useful. Um, in another convo, you had told me that BAT is clever enough to recognize when its output is being piped to another program, and so it will only pipe the quote unquote main content and not all the aesthetic stuff. Hold on, spelled aesthetic wrong. Aesthetic, I spelled aesthetic wrong again. Aesthetic, there you go. Stuff like borders, line numbers, etc. Wait, line numbers, etc. Is this true? Also, would things work the same way if I tried to pipe the output of my the output? Okay, the output specifically output from the program. Wait, okay. The output of my own Rust program. Yeah, if I tried to pipe the output of my own Rust program to some other program, I mean specifically what my program has outputted. Okay, not stuff like warnings, info, etc. It's great that you're digging into BAT. It really is the cat with wings for a reason. To answer your first question, yes, it is absolutely true. BAT uses a mechanism to detect if its standard output is a TTY, a terminal, or a pipe file, or a pipe slash file. If it detects a pipe, it automatically switches to style equals plain, stripping away the colors, headers, and line numbers, so the next program doesn't have to deal with weird ANSI escape codes or decorative borders. I forgot about that. Colors require ANSI escape codes, and so if you're printing something that's supposed to change the color, there's going to be an ANSI escape code there. Yeah. Okay, how it works for your Rust program. To get your Rust programs to behave this quote unquote cleverly, you need to understand how data streams are separated. by default, every process has three. I I should not get into this right now. You know, you know what? I should not get into this. I'm going to keep this open though. I'm going to get into this after the stream. We need to continue with polars. I'm glad I caught that before we ended up spending way too much time on this. Okay, in the example below, we write the data frame to a CSV file called output.csv. So we have our CSV file here. Well, no, we have our data frame here. We have printed the data frame, and now we have to write it to CSV. By the way, holy shit, dude. Yo, tab view is, tab view is amazing. And I prefer to compile my Rust programs from scratch, or from source, I should say, which is, in the case of Rust, a lot of times from scratch. Because like all of the other Rust stuff gets brought in. Yeah, yeah, I think so. Pretty sure it's from scratch. Even like the dependencies that are being imported, unless, again, unless it's like, explicitly packaged as a library. I think all of the I had this conversation with Gemini a while back because I was curious about this. Like, because notice how it mentions here, like there was this long list of stuff. This was when I was compiling TabView. First, it had to download a bunch of the stuff, and then it had to compile all of it. And so I was like, okay, if it's compiling everything from scratch, doesn't that mean that temporarily I'm getting the source code on my machine? And Gemini was like, yes, that is technically true. You do get the source code for all of it on your stream at the time when you're downloading this, or when you're installing. Yeah, when you're installing such a program and using cargo install specifically. Anyways, what I was saying is, dude, I will always prefer to use cargo install for installing any of my Rust applications. If that is an option, I always prefer to go with that, even if I have to use cargo install and then pull from the GitHub repo. I still prefer cargo install. That being said, holy shit, dude. Do not do cargo install for this, for TabView, unless you are willing to give at least 6 GB in addition to whatever you have on your system. Unless you are willing to give at least a good, like, not even 5, like 5 will also eventually start to, it's going to start to um what's the word to use there? A lot of people tend to use the word chug there, but like, it's, I don't know if it's accurate. Anyways, the system will start to struggle a little bit at some points. 5 GB should be enough. It's just that what happens is there's like some massive packages being compiled here, and it turns out that out of everything, the most massive packages in this were polars related packages. Multiple different polars related packages, polars SQL, polars core, polars this, polars that. There were a whole lot of polars related packages. Can I, like, would the name, is the name mentioned here somewhere? There, it mentions polars mem engine, polars lazy. There's polars IO, polars. I think this is for expressions. Yeah, I don't remember. Either way, I was installing TabView on my laptop. The laptop I'm currently streaming from. I'm on Windows right now, but I have Ubuntu installed. I was installing TabView on that, and I did not take into account that there's a chance, because like I was assuming it would be a pretty small install. I didn't know that the memory requirement would go that high. What ended up happening is, because I had like one or two other things open, which might have been taking um, a little bit of memory, not too much, but like a little bit. And because I hadn't limited the number of jobs that Cargo was allowed to use, because I wanted to use all of the cores that were available. That specific, well, this laptop has 8 cores that Cargo I allowed Cargo to use, hoping that it's going to finish the compilation fast. But uh, the machine only has 8 GB of RAM, and in this day and age, that tends to be on the low end. It's not a high end kind of thing. So what happened is, one of the Rust. So it because there were multiple jobs possible, because there are multiple cores available, and I didn't limit the number of jobs it could do. So it had the ability to compile and build like multiple packages at once using different cores for each one. And if one of the packages, compilation slash building, took 2.5 GB, and another one took, I don't know, 1.5 GB or 2 GB, we already at like 3.5 to 4.5 GB being used, right? And then if there's another package that's taking a couple hundred MB, then we are at like close to 5 GB. And in this way, slowly the memory started to build up. The first time I tried to install TabU, the system itself crashed. Like after becoming sluggish for a while, that's the word I was looking for, sluggish. After becoming sluggish for a while, it just rebooted completely, and then I restarted the installation. This time, keeping an eye on BTOP to make sure memory was fine, and this time, not running anything extra, the memory came close to filling up. Like it hit around 6 to 7 GB, I think, maybe. Well, six at the very least, 5 to 6 GB, because the OS itself takes a certain amount of memory, right? Aside from what the OS is taking, which is maybe going to be 1 GB, or I don't know, 1.5 GB or something, the rest of it is for you, right? So throughout this compilation, the maximum amount that was consumed was around 5 to 6 GB, because I remember looking at the amount of available memory, and the amount of available memory said around 800 to 600 MB at one point. So that's how I knew that, yeah, this is pretty heavy to build. But yeah, that was the experience that I had with building. Not Cargo. What am I trying to do here? Wrong thing. Yeah, that was the experience that I had with trying to build TabU. So okay, this is our script, and I'd mentioned this yesterday. I like the fact that it's formatted as a table. Uh, that's a good like aesthetic choice. In the past, I think the only time I would get this kind of a table was if I was using Jupyter Notebook. Then I would get this kind of a table. I don't remember what the pandas output looked like. It was formatted to a certain extent. I remember that. I don't remember how good the formatting was, because I do remember having complaints about the formatting. And if you wanted to change the formatting, then you had to do like some custom work there. Okay. All right. All right. So here, in the example below, we write the data frame to a CSV file called output.csv. After that, we read it back. Sorry, zoned out. After that, we read it back using read CSV, and then print the result for inspection. Okay, so first we're going to write to the CSV file. Okay, we do df.write CSV, and we want to store this in. Okay, we'll create a docs for. Do we? I think we need to create a docs folder first. Let's open up Yahtzee here. Docs. Okay, great. Docs slash. Wait, has it not? Okay. Docs slash assets slash data slash output. That's crazy. Hold on. Is this meant to be executing on like, I don't know. Okay. I'll just do output.csv. I don't even need this. Why did I do this? I don't need this. Let's do nah. Okay. You know what? Docs slash wait this. Okay. Output.csv. Okay. df underscore wait. So we have a CSV thing here. We can run this. Okay, it should be printed now. Now we can try and open this up in tab view. So let's say docs slash this. Yeah, this is our information. This is our data frame that we just created. Okay. All right. Next, the next thing we need to do is df underscore csv. Oh, you know what? Now that we've done this, we don't need this line. Now we can just read it. So pl.read csv. And again, we do dot and docs and output.csv. Try parse dates. Try parse dates is true. Okay, and then we print df underscore csv. Great. Oh, wrong. All right, so above is our initial thing, and at the bottom is our new thing. Now, if we don't parse, because like you'll notice it mentions the type. I like that it's using Rust types, because like str f64. I think it's gonna use i32 or maybe i64 for integers, and I haven't played around with dates in Rust, but this might be like a date type. So, okay, I wonder if, let's say I don't parse this. So I'm guessing because we had to explicitly specify it, I'm guessing by default it's false. Yeah, so if you look at birth date now, over here, it is currently str because it's being parsed as a string and or just read as a string. It's not even being parsed. And then it's being printed exactly as is. Okay, great. So that's done. We know how to write. We know how to read. For more examples on the CSV file format and other data formats, see the I/O extension of the user guide. Okay, expressions and contexts. Expressions are one of the main strengths of Polars because they provide a modular and flexible way of expressing data transformations. Here is an example of a Polar's expression. pl.call weight divided by pl.call height. Oh, yeah, they had to. I was wondering why it is. I was wondering why it is. What do you call it? Why this thing was grouped, but then I noticed this. So this makes arithmetic precedence a little easier, or rather, it makes it so arithmetic precedence doesn't have to be considered in this case. Because if you're just grouping all of the uh, individual operations, then each of them will be executed in the way that you've grouped them. Okay, as you might be able to guess, this expression takes the column named weight and divides its values by the square of the values in the column height, computing a person's BMI. Okay, note that the code above expresses an abstract computation. It's only inside a Polar's context that the expression materializes into a series with the results. Below we will show examples of Polar's expressions inside different contexts. I didn't understand that. So note that the code above expresses an abstract computation. It's only inside a Polar's context that the expression materializes into a series with the results. I think I'll need to read this detailed exploration of expressions and contexts. Yeah, okay. Select df.select. Let's take a look at that. And this returns a data frame. Okay, so within this we can specify the expression uh sorry, zoned out. Okay. Um, columns to select, specified as positional arguments, accepts expression input. Strings are parsed as column names. Other non-expression inputs are parsed as literals. Okay. I need to read up on this. Give me a second. Let me hydrate and then I'll continue reading. Okay, expressions and contexts. Polars has developed its own domain-specific language for transforming data. The language is very easy to use and allows for complex queries that remain human readable. Okay, expressions and contexts, which will be introduced here, are very important in achieving this readability while also allowing the Polars query engine to optimize your queries to make them run as fast as possible. In Polars, an expression is a lazy representation of a data transformation. Expressions are modular and flexible, which means you can use them as building blocks to build more complex expressions. Here's an example of a Polars expression. Okay, all right. As you might be, hold on, where are we in this, within this docs thing? So we are currently looking at what? Okay, after this we go on to installation. Oh, there's so much more that I didn't explore here. Okay. Um, yeah, I'm kind of torn on whether I should continue with this while not understanding what a context is, and how expressions work, or if I should continue here and get an idea of what a context is. And wait, back up. I'm seeing the same stuff here as here. So we are currently in the getting started thing, and here we have expressions and contexts mentioned. This is not explaining expressions and contexts. This is explaining expressions and contexts, and then it also goes into expression expansion, but this is explaining all of the stuff that would be explained here. So select with columns, filter, group by, stuff like that. Yeah, you know what? Okay, we can do that. So we can then skip this entire thing if we go through this, which I'm assuming this page is going to have more detail, more information than this. hopefully. Um, yeah, we'll go through that, and after that we can jump directly down here to this. Actually, what's in more complex queries? Oh, it's like a chaining kind of thing. Actually, is that what they're explaining? The chaining thing? Give me a second. Context and the expressions within context and the expressions within can be chained to create more complex queries according to your needs. Okay, yeah, it's talking about chaining. Okay, all right, let's read this. As you might guess, this expression takes a column takes a column named weight and divides its value by. Hold on. If I do something like this, what does it get saved into? Like, what's going on there? So for now, we can get rid of all of this reading and writing stuff, because we have our data frame being created up there already. Um, in fact, okay, now I was about to feed this entire thing into Gemini and say that, okay, based on this, give me a longer version of this. So generate more data based on what you're seeing here, but no, never mind. Okay. So we're gonna say pl.call weight divided by bracket pl.call height, um, and this is supposed to be what exactly? Power of 2. Okay, so now let's print out the type. Let's print out A first of all, and then print out the type for A. Okay, so that's just an expression. And even the type is showing up as Polar's expression. So this is just an expression. So far it's not doing anything. All right. Um, the above code, or the code above, expresses an abstract computation that we can save in a variable, manipulate further, or just print. Oh, they're doing the exact same thing that I just did. Okay. Oh, another thing I didn't notice is that, yeah, they're breaking it down here. Um, so it's reading this entire expression that I've created, and it's translating it into something that it itself can consume, like that the Polar's engine itself can consume. But then this expression has to be within a context, which we'll find out exactly what that means. But this has to be within a context for it to actually be evaluated. So far, it's just an expression. That being said, there wouldn't be an issue if I just did this, would there? Yeah, there's no issue because the thing hasn't been evaluated. It's still only an expression. All right. Um, because expressions are lazy, oh, okay, it's saying the exact, holy shit, dude. Okay. Because expressions are lazy, no computations have taken place yet. That's what we need contexts for. Contexts. Polar's expressions need a context in which they are executed to produce a result. Depending on the context it is used in, the same Polar's expression can produce different results. Depending on the context it's used in, the same Polar's expression can produce different results. In this section, we will learn about the four most common contexts that Polars provides. Select, with columns, filter, and group by. We use the data frame below to show how each of the contexts works. So this is our data frame. Okay, great. Select. The selection context select applies expressions over columns. The context select may produce new columns that are aggregations, combinations of other columns, or literals. Okay. Select BMI equals so-and-so, average. Okay, you can specify columns. But wait, where's the expression? Is the expression called BMI expression? Oh yeah, okay, it's called BMI expression. Okay, let's do this. So let's say BMI underscore expression, and then do this. Okay, result equals df dot select. Accidentally did that. Okay, right. So BMI equals expression. No, BMI expression. Um, average BMI equals. But why would that need to be a separate column? Okay, anyways, equals BMI expression dot, and we can perform various operations on this as well. We're going for mean, and then ideal underscore max underscore BMI equals 25. Print result. Okay, all right. So yeah, these are supposed to be individual, like these are supposed to be single values, the average BMI and ideal max BMI. But for the, I guess for the sake of this example and for the sake of putting everything into a uniform table size or a uniformly sized table, that's why we are doing that. Okay, cool. Interesting. So this way we can now produce a whole other data frame with these values. And then, I mean, okay, the interesting thing here would be we could then probably also join this. I guess we might do that later on. I don't know. But yeah, we might also join this to the original data frame because it has the same number of rows. So the columns would just be added on there. Okay, the expression in a context select must produce series that are all the same length, or they must produce a scalar. Scalars will be broadcast to match the length of the remaining series. Literals like numbers used above are also broadcast. What does broadcast mean? Like they created a series out of it? So just repeating the values? I need to ask Gemini about this. Note that broadcasting can also occur within expressions. For instance, consider the expression below. df.select deviation, okay. Dude, okay. I like what they've done here. They made it so you can create an expression. That expression expands into much more complex vocabulary. So let me print out BMI expression. That expression expands into much more complex vocabulary, but you are able to specify it as like a what was I saying? And this is actually not the best example. We'll see better examples once we go into more complex queries. But yeah, my point, or more complex expressions. But yeah, my point is this expression that you specify, it expands into a much more complex uh, query, which with more complex vocabulary, which if you had to do it yourself, it would have probably been a little bit confusing. And I'm guessing being able to do it in this way, just being able to specify it with very simple vocabulary, like, pl.call divided by so and so, I feel like this would simplify things greatly. And there's also the fact that you're able to like chain expressions together and maybe use expressions in other expressions. I haven't looked into that. I guess we'll see examples of that later on maybe. But yeah, okay. For instance, in the expression below, result equals df select deviation equal. Okay, that's the column deviation so and so so and so. Wait, what is this meant to be demonstrating? Broadcasting can also occur within expressions. How is the broadcasting occurring within expressions here? I guess the problem is I don't understand what broadcasting is here. Hold on. Let's ask Gemini. Hey, I'm learning polars in Python. I've noticed the word broadcasting being used here, but I don't understand what it means. Let me give it an example as well, just in case, if that helps somehow. Okay, this is, yeah, I don't want to type this entire thing out. So let's do polars, wait, docs dot polar dot rs. Give me a second. I'm just going to copy this thing to give an example so we can then understand what broadcasting is here. And this is taking some time to load. Okay, getting started. Great, awesome. Then we move into this. Then we come down here and copy what? Yeah, this. Okay, welcome to the world of polars. It's an absolute powerhouse of data manipulation, but its documentation can definitely feel a bit dense when you're just starting out. In simple terms, broadcasting is the magic trick Polars uses to make data of different sizes fit together. If you have one long column and one single value, a scalar, Polar stretches that single value so it repeats for every row in the column. Oh, okay, so it's what I was talking about. It creates a series just repeating that value. So that's broadcasting. How it works. Think of it as a way to avoid writing loops. Instead of you telling polars to add 5 to the first row, then add 5 to the second row, you just add 5 to the column. Polars handles the expansion behind the scenes. Broadcasting a scalar to a series. Um, when you perform an operation between a series, which is a column, and a single value, which is a literal or scalar, Polars Polars broadcasts that value to match the length of the series. Okay. Why length matters? The rule you quoted is Polar's way of keeping things orderly. In a select or with column context, you'll have success. You have 3 columns of length 100. Um, success, you have 2 columns of length 100 and one single value broadcasted to 100. Failure, oh, it's saying situations which would be considered failure and success. Okay. So if you have 3 columns of length 100, that's a success. If you have 2 columns of length 100 and one single value which is broadcasted to 100, that's a success. But if you try to mix a column length of 100 with a column length of 50, Polars doesn't know how to align those, so it'll throw an error. Broadcasting within expressions. Broadcasting also happens inside a calculation. For example, if you want to calculate how much each value deviates from the average, wait, I don't remember how to calculate deviation. Actually, I think it's doing it here, right? Um, BMI express. Oh, wait, it is taking one value, which is the mean, and then one value, which is a standard deviation, and wait, deviation equals the BMI minus mean divided by standard deviation? That's confusing. Okay, anyways, I mean, I can look into that later. BMI expression would represent, like, if we are doing it on select, it's going to be applied to every row, right? So this is going to return a series. I'm just trying to imagine how this would work. This is going to return a series. But BMI expression dot mean is not returning a series. It's returning one value. How do we evaluate the the one value? Okay, let's say print select, not select, df dot select, I don't know, let's say mean equals BMI expression dot mean. So this should return one value, but it should then, because this is like being done on a data frame of what, 4 rows, so it should return a series with 4 values, I'm assuming. No, it's not. It's returning one. How does that work? Is it only when you are pairing it with something that has, like, okay, um okay, how do I go about this? Can I do I don't know, weight equals um df dot call weight? I don't know if this is gonna work. Oh, it's not df, it's pl. Oh, I just noticed that. For some reason, when I was looking at PL, I kept thinking DF, not PL. PL is our Polar's library. Okay, is this gonna work? It does work. It does work. So in this way, I'm able to specify this. So what if oh, this evaluates to, so pl.call evaluates to an expression, meaning I can specify expressions within this. So I could do, um, let's say, I don't know, weight underscore mean, or average weight, average underscore weight equals pl dot call. How do I go about this? pl dot call weight dot, okay, like this, dot mean. And then this should give us, yeah, yeah. So if we have multiple, if we have even one, so like if it's a scalar and we have we have a series that has multiple values in it, then the entire thing gets broadcasted to, or expanded to the length of that series. All right, is there any more information? Okay, the peer perspective. Think of broadcasting as the automatic copy paste feature. If you have one column of 1 million rows and you want to add a status column that says active for all of them, you don't need to create a list of a million strings. You just give it one string and Polars broadcasts it. How would that work? Uh, could I just like, I don't know, let's say some val equals, would this work? I don't think this would work because this is, yeah, it's not an expression. I need a way to give an expression. PL dot, I don't know, string, value. Yeah, no, how do we do that? Hold on, let me see if, wait, can you give me an example of how to do that string thing you mentioned? Okay, in Polars, adding a constant string to every row is a classic use case for broadcasting. You don't need to manually create a list that matches the same length of your data. You just provide the string literal. Here's how you would do it. Okay, lit. It's pl.lit. pl.lit, return an expression representing a literal value. Uh, yeah, there it is. Okay, all right. I'm starting to get this. Hell yeah, dude. Um, okay, we can continue with this. Right. Let's read this again. The expression in a context select must produce series that are all the same length, or they must produce a scalar. Scalars will be broadcast to match the length of the remaining series. Literals like the number used above are also broadcast. Oh, okay. So we can either provide a number or a string. Well, okay, sorry. We can provide a number as well, not just a string literal. And if it's a number, we don't need like pl.let. We just need the number. All right. Okay. This is interesting, but why? Okay, why do they call it select? Select columns from the data frame. Yeah, that's interesting. So we select. I need to. I need to. I need to kind of wrap my head around like the concept here. Like, why is it being called select? Um, yeah, I guess I'll get it. I'll get it as we start doing more examples. Also, I like that there's entire examples here. That's pretty useful. Okay. Um, where was I? Here. Okay, note that broadcasting can also occur within expressions. For instance, consider the expression below. Df.select deviation, which is our new column, equals so and so. Okay, so when they say within expressions, I'm guessing this entire thing is being, it's because of the way that this is being evaluated. So this gets evaluated when this gets evaluated, it has multiple rows in it. So it's a series. This is evaluated, the result is a series, and then this is being divided, or the series is being divided by this. So it's another expression where we have and we have a series with a scalar being evaluated together. So again, it does that same broadcasting thing. Okay, all right, great. So far I'm understanding this pretty well. I still need to go back and understand the idea behind select. Like it says select columns from this data frame. But then in select, we are able to provide these new columns. We haven't exactly done any selecting of other columns so far. We are providing our own columns. Yeah. Okay. Um, wait, there was a thing such as, because like in Python, you have like with function arguments, you have positional arguments, and then I think they were called keyword arguments, and then there was something more. So like keyword arguments, no, actually, no, I need to understand how this is working, because if you look here, there's an asterisk and then there's two asterisks. The two asterisks, usually this is used for keyword, this is used for like a arguments dictionary. I guess this is where keyword arguments comes in. No, I don't remember. I don't remember. Hold on, hold on. Because there was something interesting surrounding this. I remember I'd done research on this a while back, but this is one of those features that because I don't necessarily always use it, so like I forget what each of them does. Um, argument, argument, no, Python function arguments. Okay. Um, okay, so we have default argument values, we have keyword arguments, we have special parameters, positional or keyword arguments, position only arguments or position only parameters, keyword only parameters. Okay, okay, all right. And then there's arbitrary argument lists. That is what this is for. This asterisk thing. From what I remember, this is how you specify arbitrary argument lists. And then below that, there's um, the double thing. I forgot the double asterisk. I think that's where keyword arguments comes in. Keyword only arguments. To mark, no, no. Oh, to mark parameters as keyword only, indicating the parameters must be passed by keyword argument, place an asterisk in the arguments list before the first keyword. Oh, this is a way to separate. This is a way to separate them. This is a way to separate your position only, position or keyword, and keyword only arguments. But then in addition to that, we have arbitrary arguments lists. So that is here. Okay, unpacking argument lists. There was another thing where you could pass in a dictionary um, containing a bunch of different keys and their values, and then within the function, the function can have like different types of functionality because of this. So like you can have one function, and depending on the set of arguments that you pass to it via a keyword, via a keyword only. Is it keyword though? It's a dictionary. I forgot what it's called. Hold on, hold on. I have to talk to Gemini again about this. In Python, there's different types of Python, or let's just say function arguments. Um, I seem to forget them from time to time. There's position, only, position or keyword, and keyword only. But in addition to that, I remember there's a thing where we can pass in a list or even a dictionary, a list or even a dict. Okay, Python argument types can definitely feel like a game of where does a slash go. Again, it's a lot to juggle, but once you see the visual logic behind the syntax, it actually sticks. Okay, the list or dict thing you're remembering refers to arbitrary arguments, often called asterisk args or asterisk asterisk KW args. So that's for keyword arguments. Okay, so these are arbitrary arguments. One of them is just a list, and the other is a dictionary. So you can then refer to each of the values by their key. Now, why was I doing this? I was looking into, yeah, I need to try and understand how df.select is working. Okay, I'm also currently learning polars. Can you tell me which of these argument, or rather, can you tell me how df.select is able to accept arguments? Okay, I just noticed something. Or, well, I just realized something that I noticed previously. This is currently taking argument lists. This is taking arbitrary argument lists and keyword arguments as well, as in arbitrary keyword arguments. So it can take a list and it can take a dictionary. So, okay, would I be able to do something like this? Let's say, okay, for the sake of, wait, what's going on here? Yeah, okay. Let's do this and then this and say weight is df dot call, no, pl dot call weight. I spelled weight wrong. And then average weight is pl dot call weight dot mean. Now would this work? Oh, yeah. I made a mistake there. Let's there. So far we are fine. Wait. Where am I supposed to be? Look. Oh yeah. Okay. This works. This works. Okay. 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 Can you tell me how df select is able to accept um random arguments? Wait, okay. One more thing I want to try. So if this is working, does that mean this would also work? For this one, let's do height instead. Okay, I made a mistake. Okay, so we pass in a list. We can't pass in a list. No, we cannot pass in a list. How do we do that? Okay, what if I did w equals pl.call weight. Is that gonna work? So let's just pass in w, and oh, that's how it works. Okay, so then we would have our, but then if that's the case, we can't really pass in the values directly. The entire, like the expression would not have a name. Oh, wait. Okay, wait. What is the, so we can't give it a custom name if we do that. But if we go for the other method, which is just this, so we can say, I don't know, vote equals W. Yeah, okay, so if we want to specify a name, we have to either use the, either not, well, basically, either use just the variable, so like we don't pass it in as a arguments list, or we pass it in as a keyword arguments dictionary, and then we can specify whatever name we want. Actually, does that work? I didn't test that. Let's change this to vote. Yeah, it does. Okay. Right. Okay. Okay. Can you tell me how df.select is able to accept random arguments? It's great that you're diving into Polars. It is famously fast, and its API is a perfect real-world example of using Python's flexible argument system to create a domain-specific language. Okay, in Polars, df.select uses asterisk args, the tuple packer we just discussed, to allow you to pass many expressions. So I was right when I looked at this and thought that, yeah, it's taking the, oh, what did I just do? Oh, okay. Um, this. Okay. Yeah, I was right when I looked at this and I said that, yeah, this takes, so this is our arbitrary arguments list, and this is our arbitrary arguments dictionary, because one uses a single asterisk and the other uses double asterisk. All right. Okay. To allow you to pass as many expressions as you want without wrapping them in a list. How it works under the hood. The signature for df.select looks roughly like this, simplified. Okay. By using asterisk expressions, Polars tells Python, take every positional argument the user gives me and put it in a tuple called expressions. Okay, and then expressions can then be unpacked internally. Okay, because of the asterisk, all of these are valid. df.select so-and-so, df.select so-and-so. Oh, this is interesting. So, okay. So what Polars, not Polars, what Gemini is saying is that um, this is valid if we just put in, hold on, what am I doing here? Okay. Let's say wait. Okay, we can delete this and run. Okay, so this works directly. We can just specify this. This should give us an error then, right? Yeah, because it doesn't exist. Though, what if I did something like this? Vote equals wait. Is this gonna work? No, what it did is it evaluated this as an expression. So it then well, okay, I don't know if saying evaluated this as an expression is really accurate to say, but um, it read that as a column name. So it tried to look for a column with that name. So if I give a wrong thing here, then yeah. So I was trying to provide like a literal, but like if I want to do that, I have to use pl.lit, or if it's a number, then I have to do this. Oh, yeah. Uh, it is not gonna do that unless it has a series along with, yeah. Okay. All right. Cool, cool. I'm starting to get this. I'm starting to slowly wrap my head around this. So apparently select works in multiple different ways. Okay. Um, right. So as much as I would like to continue streaming, I need to go cook food. That's why I started the stream a little early today, which I mean, I managed to start it early today. I I should probably try to do this like every day so I don't end up starting the stream late. Yeah, dude. But yeah, okay, that's gonna be it for today's stream. I'm not gonna raid anyone because I can't um stick around after the stream because I have to like immediately now go and cook. But yeah, that's gonna be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.